All right, so first we're going to graph the tangent function. So okay, also called arctangent. Okay, so now that we've explained it very thoroughly, we're just going to go straight to the point. Okay, cut corners here to go faster. So just make two graphs. This time they can be pretty much equal in size. Okay. On this one, we're going to go from negative pi over 2 to positive pi over 2. And this one, we're going to graph our tangent function. And on this one over here, we're going to graph inverse tangent. Okay, so you can see how they look, what's the difference, what's the similarities. So as you already know, for inverse functions, they switch. So the x of this one will become the y of this one. So this one will go from negative pi over 2 to pi over 2. Okay. The y will go from negative 1 to 1 on regular tangent. But for inverse tangent, it becomes the x. So the x will go from negative 1 to 1. Okay, same thing as you did with inverse sine, same thing as you did with inverse cosine. They switch. Okay, so here we go, guys. So for tangent, tangent's the oddball. It's the one that's different because we have these vertical asymptotes. Okay. When you graph them on the calculator, they don't show up. They're invisible, but they are there. Okay. And this is what the tangent function looks like. Okay, it goes like this. It goes through 0. Okay. It actually does, it's one right here, but it's just a sketch. Okay. And it repeats this forever on the left side and forever on the right side. Okay. It does repeat over and over and over. And you can take a quick look on your TI if you want to see it, this graph y equals tangent x, and you'll see it graph infinitely in both directions. Okay, so now I want to clarify about something in regards to domain and range. Okay, so first I want to do the domain to regular, I don't know how to say this, but to regular tangent. Because in a little bit we're going to trim it. Okay, but this is just like regular tangent, just if you plug in tangent equals x. Okay, so the domain is of this will go forever to the right, forever to the left, so it will be all real numbers. It will be that, okay? Except x cannot equal, okay, where those walls are located, the vertical asymptotes, which I call walls, right? And so they're located right here at pi over 2. And I've shown you before how it's like, every pi, you add a pi, which turns out to be n pi. Okay, that's the real way of doing it, guys. That's the real way how we write it. Okay, those of you that go into calculus or in college, like that's the professional way of writing it. But we're gonna write it in simple terms. Okay, we're gonna say this is the same as saying odd multiples of pi over 2. That's how we would say it, like in words. This is how we say it in math language, and then just in simple everyday language. Okay, and what do we mean by odd multiples of pi over 2? So like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. That's what we mean by odd multiples. Okay. So it's all the numbers except for where the vertical asymptotes are located. Is that clear, guys, so far? Are we with me? Same page? Yes. Okay. Now we're going to do the domain. Okay, before I do that domain, we do this right here. Okay, that's called the horizontal line test. Okay. We use the horizontal line test to say what piece are we going to take and reflect over here for the inverse, because we don't want to do all of it, because then it's not a function. Okay, and how do we know that? Because if I do the horizontal line test, it not only touches 3 times, it actually touches an infinite amount of times, because they go on forever to the left, forever to the right. So the horizontal line test is what tells us, hey, we need to restrict the domain and not do all of it. We're just going to do this middle part. Why just that middle part? Because that one only touches 1 time. Does that make sense? Okay. So now I'm going to do the domain, not of all of it. Let me switch colors here. Okay, yeah. Thank you. But the domain of, what do we want to call it? This piece? I don't know. This little segment. Okay. The part that we're going to inverse. Okay, so the piece of tangent. Not all of tangent, okay? I'm trying to make that clear to you. Not all of it, just that piece. So this piece just goes from negative pi over 2 to pi over 2. Bless you. But here comes my important question for you guys. Should I put parentheses or brackets on these pi over 2's? They're really important that you know the difference. Brackets, what brackets means they touch, right? Parentheses means they don't touch. So what's happening here? Can we touch these? No. So, very important, okay? And this is going to matter when we go to the unit circle. Okay. Now the range, this is actually for all tangent. It goes down and up forever, so all real numbers. Okay? Either for the segment or for all of them. They all go forever down, forever up. Are we good, guys? Any question right now? Okay. Okay, let's keep going. So now I'm going to do the inverse. Okay. So if you do the inverse, okay, I'm not going to reflect it like we did the other day, but if you inverse it, if you flip it, now we don't have vertical asymptotes. We have horizontal asymptotes because they're opposite. Okay, so the asymptotes are like this. Okay, not like this no more. And then this is what the actual graph looks like. And this you got to know, guys. You got to know what it looks like. Okay, so that's what it looks like. Okay, so it's just we took that shape and it's flipped over. Okay, that, ladies and gentlemen, is the inverse tangent function. Let's do the domain and the range of it. So the domain, notice it goes forever left, forever right. Okay, so all real numbers. And the range, that's where it's cut off, from the walls, right? From the horizontal asymptotes, so from negative pi over 2 to pi over 2. Again, parentheses or brackets? Parentheses, right? Because we can't touch those. Okay, this matters a lot, okay? Because you got to connect this with the unit circle. When we go look at the unit circle here in 10 seconds, we can only look at from negative pi over 2 to pi over 2. We can't look at the whole circle, just from here to here. Is that okay? You with me? Any questions right now? No? Okay. Let me separate video because this